Hello everybody, my name is Kevin Couling. I'm a PhD student here at WMG. Now my area that I've been studying the last couple of years is 3D printing of perovskite solar cells. So as with the previous slides, we've been looking at energy things and printing solar cells. However, the topic for me here today is the nerve for 3D printing for surgical training. Now, because I've learned so much about 3D printing, you get talking to people and you start asking questions. So Phil's got that questionnaire up at the moment asking you to ask questions. Everybody's always got a question for something. So if I can start at the beginning of this story for me, for my studies, I started off here at WMG learning about 3D printing. Now 3D printing is a very broad spectrum. You can print almost anything at the moment, but like most stuff, it's still young. And we're learning so much. There's so many questions we don't have. So for example, just above me, solar cells, we can already print them flat. But what about if we can print them on another dimension, over a car, say, for example, or even onto a fence, onto a wall? Then there's houses. They're already able to 3D print houses on large scales. It's still young, and whilst it's a very slow process, it's easy to drop a computer in a robot in one place, walk away, and come back a few days later, you've got a house. And then there's very small scale features like this one next to the match, that's micro printing, and we can even go as far as nano features, which is smaller than the hair on your head. This little boat to my side here, this one's quite a nice piece because it's got multiple colors. We're now learning to integrate colors into a component, which is expanding on what we can do with the technology. Now 3D printing recently really came alive. COVID-19, whilst it's not the nicest thing we've had to go through, for me as an engineer, it's been one of the greatest points where engineers have come together to help support a cause. The WMG made face shields for the NHS locally and other organisations that were out there on the front line working just like above, and there were some people at home with their children 3D printing and supporting this cause. To the side of me was one device we made for a hospital to help protect surgeons during operations. But these are all very hands-on items. And then this end piece, we 3D printed tooling for an injection molding machine, which can make parts even quicker. Coming back to the original question though, because these are all fairly simple devices, training, learning, what do your doctors have to go through? They practice, practice, practice. This image of a hand over on the side here with all the nerves, the veins, the bones, the muscles. Your doctor needs to know when he's about to operate on you, every single feature. You trust that person wholeheartedly. Somewhere though, they have started. This little clay model to my side is how some undergraduates currently learn. It's very simple. It can take days to get ready. The only other options are what's called a cadaver, which is a dead body, volunteered usually before they pass away to give their bodies to science. Unfortunately, they're very low in, you can't really get them off the shelf. That's the easiest way to explain it. So we need another option. And another option is 3D printing, because you want your doctors to know what they're doing. I myself want to know that my doctor has had an education and is trained, and I am not his first guinea pig that he's practicing on. So I can wholeheartedly say education is very important. For me, it was very important. However, when I left school, I didn't have any A levels. I had the capacity for GCSEs, but my teachers felt it wasn't quite the thing for me. Being an engineer, I love my engineering. I went away and did a BTEC national diploma because at the time, that's what I thought I could do. However, like most engineering things, I absolutely loved it. So I went away, did a BTEC national diploma, and then went to work for a Victorian railway, driving steam trains. It's old school, it's large, heavy, it's engineering. One of my bosses there pushed me and I realized I had the capacity to do more. I went to university. I did CAD models like the train above. I learned how the internal combustion engine works and did dyno testing. And even naturally being a motorcyclist and an engineer, I have a bike and I was able to test and put those principles into practice. But not being satisfied, I pushed myself further. So above me was an experiment with another university. They were looking at people with facial blindness. I can wholeheartedly, if I don't see a family member for a couple of months, I can walk past them and not recognize them. I have what's called a facial blindness. Thankfully, there was no operation. They put loads of sensors on my head, and I was genuinely a guinea pig for the day for them to find out more about this. It's not a disease, but this understanding so that they can better determine what people go through with these situations. This university got me into 3D printing, doing a PhD. Now we have some pretty nice technology here at WMG within the scanning department. We have this lovely scanner which can be handheld. However, because it's very fine resolution down to the microns, it needs a robotic arm to help stabilize it. It's great for external features on a finger. However, it can't see inside the finger. This little dodo to my side, he was a recent test for the CT scanner, which uses X-rays to look through it and to see the features inside. This is the kind of technology we would want to see inside a finger to train a doctor, but unfortunately, I don't fancy taking my finger off and sticking it in the X-ray machine because there's a lot of radiation in there to expose yourself to. So once we'd scanned my volunteer finger from the outside, I then put it onto a 3D printer. Now I'm going to ask my colleague to put this video up for us, please, and then I will explain it a little bit more detail. Now this is just like your domestic inkjet printer. The only difference is it's not printing just an ink for an image, it's printing an ink that's going to have a light that's going over the top of it to cure it. So if you could kindly play that, please, Phil. Thank you. Now each of these layers is only 40 microns. Now we have sped this up, so this isn't growing this quick. This is a 2-hour long print to get this finger to print, and that head is going over and over again, like I said, at 30 microns, and building that finger up detail upon detail. And that white bit of material underneath is a support material. You can't at present print on air, so you need something to be underneath it for it to grow. But I know this video is probably not what you want to see. So if you wouldn't mind finishing there, please, Phil, and if you can kindly hand back to me, please, I will show you the real finger. All right, thank you. Now, for everybody out there, this is my finger. This is the printed one, and this is the real McCoy. They are both there. You can see my nail. You can see the wrinkles on the back. I hope you can see them. Now, if there is a school interested, we are happy to send a few of these out because they only take a couple hours, but believe it or not, adding one more on only takes another 2 minutes. But these, whilst these are just a solid lump at the moment, this one is very flexible. This one is very soft. So inside that, we can print a bone. So I can make a practice bone, but in the real world, you get the CT scan and do it. This one is a little harder. And then this one is solid. Okay, so we can change the hardness of the material, which allows you to practice, which means we can take a CT scan and we can put the veins in, the nerves in, and the bone features in, and we can print that in one piece, which means when your surgeon comes round to say, look, I'm going to operate on your finger, and you can ask him, what experience have you got? He can say, I've had hundreds of practices on little plastic ones, which means he knows a lot more what he's doing because he's had good practice. Now, there's loads of questions. For me, when I was in school, this technology didn't even exist. And by the time some of you get into university, if you go into uni, this could be prehistoric technology. They're now making plastics that feel. So within the last month, they're now able to make a plastic that feels and reacts like your skin, which means we're getting even closer to being able to 3D print lifelike features, or even we are also printing bio products to make real features to print directly to your body. This is all amazing stuff. I'm sure you've got loads of questions. I can promise you we will do our best to answer them. And if we don't know, somewhere there is a scientist out there who will happily take it on to learn some more. And thank you very much.